good afternoon, guys, or good morning, or wherever you're watching this video. This is chapter 9.1, and we're going to try something new. So this is going to be the actual lesson, so make sure that during this you're taking notes and you're pausing it when you don't understand something. So, chapter 9.1 is a pretty easy chapter. It's just about the greatest common factor. And remember, what a factor is are two numbers that when multiplied make up another number. So for instance, the number 60, factors of it could be 6 and 10, could be 3 and 20, could be 15 and 4, and because 15 times 4 gets you 60. Also, 1 times 60. So if I were to look at the greatest common factor, well, you would need another number, and you'd have to find the factors of that number. So greatest common factor, let's say it was 30. So I'm looking for the greatest common factor between the two of them. So 30, you could do 15 times 2, 30 times 1. And we know that 30 is going to be the biggest factor because there's no other number times something else that will get you 30. And 30 is also a factor of 60, 30 times 2. So you can say that the greatest common factor is 30 because it's the greatest number that's a common amongst both of them. And they're both factors of each number. So that's greatest common factor. Well, you could do the same thing in algebra. So sometimes you are going to see two numbers, and you might know right away what the factors are. So if I say, what is the greatest common factor of 120, or 100 and the number 20, well, you could probably do this in your head because you know 20 times 1 is the greatest. 20 is going to be the greatest one for 20. And 20 is also a factor of 100 because 20 times 5. So sometimes it's really, really easy. Greatest common factor is 20. Sometimes it's not as easy. So, for example, if I said something like 970 and 544, you might not know all the factors or be able to do all the factors for each of them in your head. So one way that we can do this is we can use the prime factorization of the number. And that's another thing you learn in chapter 9.1. Now, the prime factors, or the prime factorization, is taking a number and breaking it down into its prime factors. Remember, factors are numbers that the only things that go into them are 1 in itself. For instance, the number 7 is a prime number because other than 7 and 1, there's no other multiplication problem. There's no other factors that can get you 7. Whereas 36, you have 36 times 1, but you also have 6 times 6. So this is not prime. We would call that composite. So the prime factorization is going to be taking a number and breaking it up into its prime factors. So if I asked you to do the prime, and you're going to see why we're doing this in a second, because it helps you with greatest common factor. So if I asked you to do the prime factorization of 50, well, we can do the prime factorization by making a tree diagram. So first of all, I think of two factors of 50. So doesn't matter which one you start out with. I'm going to start out with 10 and 5. You'll always end up with the same answer no matter what the first two numbers are. Now I asked myself, is 5 a prime number? And since you could only break it down into 5 in itself, it is a prime number, so I'll circle it. But 10 is not prime because other than 10 and 1, you could also break it down into 5 and 2. Well, the 5 and the 2 are prime factors. So to get to 50 using only prime numbers, I'm going to use these numbers, but I'm going to write them in least to greatest. 2 times 5 times 5. This is the prime factorization of the number 50. Some people also can write it as 2 times 5 squared. But it's actually better. You'll see why later, why it's better to do that. So let me give you another example. Let's do the prime factorization of 120. Well, let's start off with, it's a 0 on the end, so whenever there's a 0, I know it's 10 times something. So 10 times 12. Neither of those are prime, so I'm going to go into 12 is 4 and 3. Well, 3 is prime, but 4 can break down into 2 and 2. Well, now the 10 on this side can also break down into 5 and 2, which are prime factors. So the prime factorization of 120, you can get to 120 by doing 2 times 2 times 2 times 3 and times 5. We could also do this with negative numbers as well. And negative numbers are really, really easy because all you have to do in the very beginning, let's say I had negative 36. The very first thing you always want to separate into negative 1 times the positive 36. And you count that negative 1 as a prime factor. And then we're going to go off and keep going until we get into its prime factors. 6 could be broken down into 3 and 2, and that 6 could be broken down into 3 and 2. So the prime factorization of negative 36 is negative 1 times 2 times 2 times 3 times 3. And again, that's the prime factorization of that number. Well, let me show you how this works out, why this helps in when we're doing the greatest common factor. Now I'm going to do an easy one that we might have known this one right off the bat. Let's say 28 and 36. And the directions are to find the greatest common factor. So again, we're not looking for the prime factors. We're looking for the greatest number that goes into 28 and 36. And you might be able to do this in your head. You might say, okay, well 7 times 4 is 28, 4 times 9 is 36. And you might be able to come up with a number right there. And if you can do that, you don't have to go through the steps. But if you can't, what you're going to do is you're going to take the prime factorization of each of the numbers. So 28 is 7 and 4. 7 is prime. And 4 is 2 and 2. And for 36, you could go 6 and 6, and then 3 and 2, and then 3 and 2. So what I'm going to do is I'm going to write the prime factorization of these numbers right on top of each other. So 28, you have 2 times 2 times 7. And for 36, you have 2 times 2 times 3 times 3. Well, if you find what's common, the prime factors, they each have a 2, and they each have another 2. So what they share are 2 2's. And if you multiply those of what they share, you get 4. And that 4 is actually the greatest thing, the greatest factor of both 28 and 36. Now you might have known that right off the bat because you could have said, well, wait a minute. 28 is 7 times 4, so 4 is a factor of both of them. And 36 is 9 times 4. So you could do this in your head this way, or you can do the prime factorization and find out where they overlap. Let me show you that one more time. Let's say we had two big numbers, like 120 and 80. And we want to know what is the GCF. So again, you might be able to figure out all the factors of 120 and all the factors of 80. But if you can't do that in your head, you can break them down into its prime factors. So I'm going to go 12 and 10, 5 and 2, 6 and 2, 3 and 2. So the prime factorization, again, these aren't the factors, these are the prime factors. The factors are things like 12 and 10 or 60 and 2. But the prime factors are going to help us find the greatest common factor. So prime factors of 120 are 2 times 2 times 2 times 3 times 5. Now let's do the prime factorization of 80. We'll do 40 and 2. 2 is prime. Then 20 and 2. Then 4 and 5. 5 is prime. And then 2 and 2. So the prime factorization of 80 is, let me make sure I get all the 2's. There's 1, 2, 3, and 4 2's. So 2 times 2 times 2 times 2 times 5. And notice how sometimes I cross them out to make sure I get all of them. So to find the greatest common factor, a number that goes into 120 and also 80, what I'm going to do is I'm going to go, instead of highlighting, I'll circle them because you probably only have a pencil. So right here they share this 2. They share another 2. They share a third 2. This one does not have a partner, but the 5's they share. So what they share are 2 times 2 times 2. See these 3 2's right here? They share 3 2's and they share 5. And if I multiply all those together, 2 times 2 is 4, times 2 is 8, times 5 is 40. So the greatest common factor of 80 and 120 is 40, which again, you might have gotten if you just would have said, okay, well, 40 times 3 gets me 120, and 40 times 2 gets me 80. But you would have had to make sure that was the greatest number. And the prime factorization ensures that you get the greatest number that goes into both of them. Right? So there's one other little small thing that is with this is sometimes we could add variables, but variables are really easy. So if you have 8x squared y to the fifth and 12x to the third y, and I shall make that a negative 12, and I'm asking you for the greatest common factor, well, I'm going to show you both ways that you could do this. First of all, think of the things that go into 8. This is more of so not using the prime factorization, but just in your head. So you have 8 times 1 and 4 times 2. And I know, well, 4 times 3 gets me 12. So 4 has to be the greatest common factor of them. They also, this one, if I were to break it out, this x squared means x times x. And y means y times y, and you can do that 5 times. This one has x times x times x times y. So what do they share as far as the variables? Well, they each have 2 x's, and they each have they have 1 y that they share. So in our greatest common factor of these two numbers, we're going to make sure we keep those highlighted. But let's just double check that the answer is 4. So let me do the prime factorization. So you get 4 and 2, 2 and 2. So the prime factorization of 8x squared y to the fifth would be 2 times 2 times 2 times x times y, y times y times y. And then of negative 12, remember, I'm going to write that down here. Remember, you factor out a negative 1 first, and you get the 12. And then it breaks into 6 and 2, and then 3 and 2. So the prime factorization of negative 12 would be negative 1 times 2 times 2 times 3. So again, oh, and then I'm sorry, and then I forgot the times x times x times x times y. So right here, I'm looking for what do they have in common. They don't share a negative 1, but they share a 2, a second 2. That's the only numbers they share. And then remember, just like I highlighted them before, they each share 2 x's and 1 y. So the GCF would be 2 times 2, because they share 2 2's, which is, like what we said in the beginning, 4 x squared y, because they each both have an x squared and a y. All right, so I hope that helps with GCF, and then we'll work on this tomorrow.